Hi everyone, I'm Prerna Shekhar and today I'll be presenting my project Video Search Enhancer. The goal of this project is to extract audio information from videos and convert it into text and index them by enhancing the video search experience. So now I'll share my screen and let's see how the current video search experience is. So let's say I want to know about specific details. Let's say I want to know the sunlight requirements of a plant called pothos. I would go on YouTube and search for sunlight pothos. This would result me in a number of videos which talks about the pothos plant care in general and not about the sunlight requirements. So the only way to understand about the pothos sunlight requirements would be to seek through the video or watch the entire video and then understand the exact sunlight requirements. The aim of my project is to target this problem. So this is the video, this is the UI of the web UI platform which I have developed. And now let's say I search for sunlight pothos here. This would highlight the videos which talks about sunlight requirements of pothos, and when I play the video it would start right from the moment where they talk about the exact sunlight requirements.
Extra sunlight in order to be able to produce the food that it needs in order to be able.
So as you can see, this definitely enhances the video search experience. Now let's look at the system architecture diagram of this project. The entire project is built by utilizing the Google Cloud Composer. The Google Cloud Composer is built on top of Apache Airflow, which is composed of DAGs, and a DAG is composed of multiple tasks. So here I have utilized a single DAG, which is made up of 3 different tasks, which takes the input YouTube URL and converts it into an audio MP3, and the audio MP3 is then converted to text with its word timestamps, and the indexed, transcribed, and the word timestamps are indexed to form a JSON, which is then fed into an Algolia search engine. So the process would be as follows. The required YouTube video URL would be uploaded onto a Google Cloud Composer. When it is uploaded, it would trigger the first task. This YouTube video URL first task, it utilizes YouTube DL Python library, and it converts the given YouTube file into an MP3 format. And once it is processed, it stores the MP3 file on the Google Cloud storage in a Google Cloud bucket. Then the second task will be triggered, which takes the data from the Google Cloud storage and it indexes every word with its relevant timestamp. Then once that word with the relevant timestamp has been given as an input to the third task, it triggers and it generates a JSON file with the relevant timestamp mapping indices. And that is then inputted, and that is given as an input to an Algolia search engine. Then I have built a UI web interface using React app, which utilizes Algolia search engine in order to enhance the video search experience. So now let's take a video and let's look at the end-to-end flow of this particular project. So let's say we want to upload this YouTube video and index it. I would first go on to my code. So this is the code. And here's the place where I would place my YouTube URL. Let's save this. So this has a DAG, which has 3 tasks, which is mentioned here. The very first task is converting video to MP3. This task utilizes a YouTube DL Python library. The YouTube DL Python library uses FFmpeg extract audio in order to convert the given YouTube video to an MP3 format. However, in order for this application to work on the task, we need to install the FFmpeg library on the worker node. But Google Cloud Composer does not allow us to directly install these stuff. Therefore, I have created a container image with all the relevant necessary libraries installed on it. Therefore, it utilizes this container image and then converts the given video file into an MP3 format. Now let's go ahead and upload this video file onto our Google Cloud Composer. So this is a video enhancer Python file, so let me upload it. So I'm replacing my file with an updated content. This is the Apache Airflow web interface, which indicates the 3 tasks which we have specified. Now let's go ahead and see if our code is updated or not. Yes, looks like it has the latest YouTube URL. As you can see currently, none of the tasks are running, and the bucket which holds the MP3 file is also empty. So now I will trigger this DAG. So as I trigger the DAG, it triggers the very first task. It takes a few seconds to reflect. When the task is running, it indicates in light green color, and once it is completed, it turns to dark green. Okay, well, now the very first task has triggered, and it is converting the uploaded YouTube URL into an MP3 format. So once this first task is completed, then the second task, convert MP3 to speech, would be triggered. So this task, convert MP3 to speech, would fetch the created MP3 URL from the Google Cloud bucket, and it utilizes Google Cloud speech-to-text speech client API and converts it into a text format with the relevant word to timestamp indices, and it sends the results. As you can see here, the first task is completed, and let's look at the logs of this. It indicates that the first task is successfully completed and it has succeeded. Now the second task has kicked off, which is converting the given MP3 into a word to timestamp mapping. And we can look at this chart, which tells us how much time every task is taking. So it nearly took 26 seconds to convert the given video file into an MP3 format. And now, since the first task is completed, if we refresh our Google Cloud bucket, we should have got our MP3 file. Yes, we can see that the file is uploaded onto the Google Cloud bucket. Now the second task is completed, and it is going to kickstart the third task. So we can see that the second task took nearly 45 seconds to complete. So as soon as the second task is completed, it would give the indexing of word to timestamp, and which would then be, and then it is given us to the third task, which is the indexing speech to search, which would index every single word with its relevant indices. And okay, now the third task is completed. So once the third task is completed, it would output a JSON file, and it would dump it onto an Algolia search engine. Here we can see that there are currently 9 records. So the third task is completed. So if we refresh this file, we should be able to see the new record. Okay, now we can see that the 10 records have appeared here. So it has been uploaded onto the Algolia search engine. And this is the front-end code which I have written in order to index and highlight the words which we search for specifically. Now, if we look at our web UI, we should have got the new video which we have uploaded. Yes, so this is a video which we uploaded and it is here. And totally and now if we want, we can look at the total time taken in order to process. So it took nearly 26 seconds for the first task, 45 seconds, and then approximately 16 seconds for almost a 1 minute video. So now, so there are, as you can see here on this web page, there are a couple of videos which talk about various indoor plants about it. So now if we want to specifically understand where in the video where they have spoken about a specific plant, then we can directly straight away search, say peace lily, and it would filter out and show us all the results which talks about peace lily, and the video would also start from the exact timestamp where the video talks about peace lily.
One is a peace lily, and I love this plant because not many plants that...
Yes, let's play the second one.
Also called peace lily, beautiful wide green leaves on it, great for...
So this highlights the specific content which we were looking for, and the video plays straight from the point where the video talks about peace lily. Hence, this helps in enhancing the search experience, and it increases the efficiency and the user experience. Thank you.